Hi everyone, today's video is on modeling using similarity, and when we say modeling, we're basically saying we want to apply this to some kind of real world situation. So here's the first exercise. You have a very simple drawing here of a person and a tall building, and it says you want to determine the approximate height of one of the tallest buildings in the city. And what they set up is they said, well, if you put a mirror right here on the ground and you set it up so that this person could see, this is this line of sight, this person is looking at the mirror, they can just see the top of the building in that mirror. Alright, so they've set up two triangles. You've got triangle AOB, or actually I should name it the same as over here. This is triangle ABO, the smaller one over here, and the larger triangle is triangle STO. And the first thing I want to do is explain why we know that triangle ABO is similar to triangle STO. Alright, well, if you remember, how did we prove that two triangles were similar? Well, we had to prove two things, or we had to state two things that were true. We needed two corresponding angles to be congruent. Well, if this person is standing straight up and down and this building is straight up and down, which we hope is the case, we can assume that the angle with the person and the ground, angle B, is 90 degrees, and that the angle made by the building and the ground, angle T, is also 90 degrees. Alright, so we can say that those are congruent. So there's one set of angles, and they give us in the problem the way you hold the mirror, the line of sight of the person and the line straight to the top of the building, well, those are both 40 degrees. So angle, and I'm going to have to name this with three different points here. Angle AOB, meaning this angle right here, is also congruent to angle SOT. Alright, so there are two angles that we know are congruent and they're corresponding, so that allows us to conclude that triangle ABO is similar to triangle STO. Alright, so that is part A, just a little explanation there, no math to that. But let's take a look at the next question that they ask us to do. The next, they want to know, what is the distance from the mirror to the building? Alright, well, you have to fill in what they told you. Notice this is part C. So you have to fill in what they told you in part B. And I'm going to take a minute to do that, and then we'll do part C. So what I did is I labeled everything they told me in part B. And make sure you labeled this one right. This was a little confusing. They said the distance from eye level to the ground. So that would be from where this person's eyes are straight to the ground. So that's why I labeled this one 5.3. And part C wants to know, what is the distance from the mirror to the building? So they want to know what this distance is right here. And that's pretty easy actually, because they gave us from the person to the building to be 1750. And I'm going to add a decimal there because I know what I'm going to do here. And the distance from just the person to the point O, where that mirror is 7.2. So if I take that 1750 and take away 7.2, well, I get 1642.8 feet. Okay, so the distance from the mirror to the building would be 1642.8. And I could put feet on there if I like. Okay, so here's part D, and they want to know, do you have enough information to determine the approximate height of the building? And so I'm going to go ahead and put the height of the building, I'm going to label that with an X. And it says, if yes, determine the approximate height of the building. Well, it looks like we do, because we have two similar triangles, and we have a corresponding side with the 7.2 to be 1642.8. We have the height of the person to be 5.3, and that corresponds with the height of the building. So just like we did before, we could set up a proportion between these sides. Alright, and like I did before, I'm going to go small triangle to large triangle, the 7.2 corresponds with the 1642.8. And again, I'm going to go small triangle. The side that's labeled 5.3 corresponds with the height of the building. So I have a proportion. I solve a proportion by cross multiplying. So I'm going to cross multiply, and I need my calculator up here. So I take 1642.8 and I multiply by 5.3, and that's 8706.84. And now I have an equation, and I'm going to solve for x. So I divide by 7.2, and I divide by 7.2 on both sides. And I need my calculator again. So I need to divide that by 7.2. And oh, that's not a pretty number, but it's an approximately. So I'm going to round this to the nearest tenth. So it's 1,209.3 feet. And make sure you put the units on there at the end so that you make sense of the problem. Okay, so that's number 1. Now here is number 2, and it says a geologist wants to determine the distance across the widest part of the lake. So that is this distance right here. Alright, the geologist marked off specific points around the lake so that DE would be parallel to BC. Alright, and so what it does is when you look at these lines that they've marked off, basically you have two triangles here. You have triangle ADE and you have triangle ABC. Alright, and if you remember, we had a problem similar to this before where the triangles, they overlapped each other. And when these two lines are parallel, well, that tells us that we were able to conclude that these two triangles were similar. Okay, so we know that these two triangles right here are similar. I'm going to write that right over here. ADE is similar to triangle ABC. Alright, now part A says, has the geologist done enough work so far to use similar triangles to help measure the widest part of the lake? Alright, and since we can conclude that triangle ADE is similar to ABC, because of those parallel lines, alright, the geologist has done enough that they should be able to use similar triangles to do a little math here to figure out that widest part of the lake. Now we're going to switch over to part B, and I'm going to label what part B tells me. So I went ahead and I labeled the information that I have, and they want to know, does she have enough information to complete the task? Alright, and this one, a little hard to see if you're not sure. I'm going to put my X there, but once I explain it, I think it's pretty obvious. We need some corresponding sides. Alright, and we need corresponding sides for this small triangle, which is similar to this large triangle. We said that before, okay? And, well, do we have that? Well, sort of. We do, but it's not very apparent right now. We have side AE and we have side DE, but we don't have a big side of the triangle. Oh, but maybe we do, because if I put 7 together with 15, that would be the whole length of this side right here. So knowing this is 7 and knowing EC is 15, I can know that this is 22 feet right there. Alright, so she does have enough information to determine the length of BC. So I'm going to go ahead and do that now. I'm going to say small triangle AE to big triangle DE. Small triangle AC to big triangle BC. Alright, and now I'm just going to plug in the numbers. AE is 7, AC is 22, DE is 5, and BC is x. And there I have a proportion. And you know how to solve a proportion. You cross multiply. 7 times x is 7x. 22 times 5 is 110. If I divide both sides by 7, well, that means x is something. I gotta grab my calculator and figure that out. So that's 110. Oops, not 1,110, just 110 divided by 7. And what do they say to the nearest? We want to go to our lake. No, we're just going to round to the nearest tenth. So 15.7 would be the widest part of the lake. Okay, so sometimes they don't really give you the information right straight ahead. You have to do some manipulation first. For the last part, part C, it says assume the geologist could only measure a maximum distance of 12 feet. Could she still find the distance across the widest part of the lake? And what would need to be done a little differently? Well, I'm going to put up the information that we had from the last question. And if she can only measure 12 feet maximum, the problem is she wouldn't have been able to measure this distance right here from E to C. Okay? Now there's many different ways you could get around this. One easy way is, could she have cut up this distance into parts? Alright? What if she started here and she said, well, I can only measure a distance of 12 feet. So she measures the 12 and she gets 12 feet from there. What would stop her from just simply starting over and measuring from here to here and get 3 feet and say, well, there you go, I've got 12 feet and 3 feet, that means 15 altogether, and she would be good to go. And I think that's the easiest way to answer that question right there. I'm going to turn off this other layer to clean it up a bit. So I think that would be, you know, an easy way around it, is just to measure it in parts. And then she could do the same proportion as she did for the other. Alright, so pretty straightforward. Once you get past that, adding the 7 and the 15, you get the longer side there, and you can figure out the widest part of the lake. Alright, so hopefully that was clear to you. If you need to watch it again, go ahead. Thanks for watching, and we'll see you tomorrow.